Yeah, welcome back everybody. Today we're going to continue with the proofs of trigonometric identities. Let's go straight to it. The first one is show that cosec theta minus cot theta, cosec theta minus cot theta times cosec theta plus cot theta equals 1. As usual, I'm going to show that the left hand side is equal to the right hand side. Let's write what the left hand side is. Cosec theta minus cot theta times cosec theta plus cot theta. Now, we can see that this product, cosec theta minus cot theta times cosec theta plus cot theta, is a difference of two squares. So I can write it as cosec squared theta minus cot squared theta. Now this simply means I know that cosec squared theta is the same as 1 plus cot squared theta. Let me show that. Sine squared theta plus cos squared theta equals 1. If I divide this equation through by sine squared theta, I'm dividing through by sine squared theta. That simply means 1 plus cos squared theta over sine squared theta is the same as cot squared theta equals 1 over sine theta is cosec theta. So 1 over sine squared theta is the same as cosec squared theta. Of course, if you say 1 over sine theta and you square that, 1 over sine theta is cosec theta. So when you square it, you have 1 squared, which is the same as 1 over sine squared theta. And that's the same as cosec squared theta. So instead of writing cosec squared theta here, I'm going to write 1 plus cot squared theta. So that means 1 plus cot squared theta equals 1 plus cot squared theta minus cot squared theta. Yeah, cosec squared theta minus cot squared theta is the same as 1 plus cot squared theta minus cot squared theta. Let me erase this. And I can see that cot squared theta minus cot squared theta is 0. And the answer is 1, which is equal to the right hand side. And that's a proof simply. Now let's go straight to the next. The next one is show that cos to the fourth power of theta minus sine to the fourth power of theta equals 2 cos squared theta minus 1. 2 cos squared theta minus 1. Now, as usual, left hand side is equal to cos to the fourth power of theta minus sine to the fourth power of theta. That simply means cos to the fourth power of theta can also be written as a square. For example, if I say x raised to the power 4, x raised to the power 4 is also a square, but in this case it is the square of a square. I can write x raised to the power 4 as the square of x squared. So that means x raised to the power 4 is also a square. So that's the same thing I'm going to do here. I'm writing cos to the fourth power of theta as a square. And that simply means the square of cos squared theta minus the square of sine squared theta. So now I can express both of them as a difference of two squares, which simply means cos squared theta plus sine squared theta times cos squared theta minus sine squared theta. Don't forget what we want to show that it is equal to. We want to show that it is equal to 2 cos squared theta minus 1. So cos squared theta plus sine squared theta is 1 times cos squared theta minus sine squared theta. Now I can write cos squared theta in terms of sine squared theta, and that simply means, of course, 1 times this is the same as cos squared theta minus sine squared theta. And that simply means cos squared theta is the same as 1 minus sine squared theta. What do I really want? okay, I want 2 cos squared theta. It is cosine I want in my answer. So I'm going to, it is sine that I'm going to write, sine squared theta that I'm going to write in terms of cos squared theta, and not cos squared theta in terms of sine squared theta, because what I need in my result is cos squared theta and not sine squared theta. So instead of writing sine squared theta, I'm going to write 1 minus cos squared theta. So this simply means cos squared theta minus, open bracket, 1 minus cos squared theta. And that simply means cos squared theta minus 1 plus cos squared theta, which simply means 2 cos squared theta minus 1. And that's the right hand side. So you must always take note of what you are showing that it is equal to. Now, we go straight to the next, which is show that sine, I think this is just similar to what we just did, sine to the 4th power of theta minus cos to the 4th power of theta equals 2 sine squared theta minus 1. The left hand side is sine to the 4th power of theta minus cosine to the 4th power of theta, and that is same as the square of sine squared theta minus the square of cos squared theta, just to express it as a difference of 2 squares. And this simply means sine squared theta plus cos squared theta times sine squared theta minus cos squared theta. And that's equal to, what do I need in my result? I need sine squared theta. So I'm writing cos squared theta in terms of sine squared theta. Sine squared theta plus cos squared theta is 1. So 1 times sine squared theta minus cos squared theta is sine squared theta minus cos squared theta. 1 times sine squared theta minus cos squared theta is sine squared theta minus cos squared theta. And that simply means sine squared theta minus, open bracket, 1 minus sine squared theta. Cos squared theta is the same as 1 minus sine squared theta. And that simply means sine squared theta minus 1 plus sine squared theta, which is equal to sine squared theta plus sine squared theta is 2 sine squared theta minus 1. And that's the right hand side. And that's the right hand side, which is a proof very, very simply. We go straight to the next one. 1 all over, show that 1 all over sec theta, show that 1 all over sec theta minus 1, I have to write that well, 1 all over sec theta minus 1 plus 1 all over sec theta plus 1 equals 2 cos theta cosec squared theta equals 2 cos theta cosec squared theta equals 2 cos theta cosec squared theta. Now the left hand side is 1 all over sec theta minus 1 plus 1 all over sec theta plus 1. Now here I can find the LCM. The LCM of the denominators is sec theta minus 1 times sec theta plus 1. Now if I divide this LCM by sec theta minus 1, I'll be left with sec theta plus 1. Sec theta plus 1 times 1 is sec theta plus 1. Now, in the same fashion, if I divide this LCM by sec theta plus 1, I'll be left with sec theta minus 1. And I'll multiply that by 1 to have sec theta minus 1. Now, what's the next step? The next step is sec theta. Okay, now I can see that 1 minus 1. I want to move this down a little for proper spacing. Yeah. Now I can see that 1 minus 1 is 0. And sec theta plus sec theta is 2 sec theta. 2 sec theta all over The denominator I can see now is the difference of two squares, which can be written as sec squared theta minus 1. Yes, sec squared theta minus 1. We'll see that if we simplify that, we're going to get sec theta plus 1 times sec theta minus 1. And that is equal to 2 sec squared theta. What did they say we should show that it is equal to? Okay, we should show that it is equal to 2 cos theta cosec squared theta. Okay, and that denominator can be written as sec squared theta plus 1 is the same as, we remember that 1 plus tan squared theta equals sec squared theta. How did I get that? Just go from here. Sin squared theta plus cos squared theta. Sin squared theta plus cos squared theta equals 1. Divide through by cos squared theta. If you divide this through by cos squared theta, divide through by cos squared theta, you're going to get sin squared theta over cos squared theta is the same as tan squared theta plus cos squared theta over cos squared theta is 1 plus 1 equals 1 over cos squared theta is sec squared theta. So 1 plus tan squared theta is the same as sec squared theta. Yeah, 1 plus tan squared theta is the same as sec squared theta. That simply means tan squared theta is the same as sec squared theta minus 1. So instead of writing sec squared theta minus 1 here, I can write tan squared theta. Yeah, that's what it means. Let me erase this. So tan squared theta is equal to sec squared theta minus 1. Tan squared theta is equal to sec squared theta minus 1. And that simply means this denominator, which is sec squared theta minus 1, this denominator, which is sec squared theta minus 1, is the same as tan squared theta. Now, this simply means 2. What are we showing that it is equal to? We are showing that it is equal to 2 cos theta cosec squared theta. Okay, this is the same as 2 sec theta times 1 over tan squared theta. And that simply means 2. Okay, I know too that, okay, I think I can go this way. I know that sec theta, yeah, I'm still on the right track. I know that sec theta is 1 over cos theta. So I'm writing that as, let me write on the next line. I'm writing that as, that's a trick. You just have to take a few seconds to check that you are following the right step. You are following the right steps so that you don't get to the end and see that you didn't do the right thing. What I need is cos theta and cosec squared theta in my answer. So sec theta is the same as 1 over cos theta times 1 divided by tan squared theta is simply the same as 1 divided by sin squared theta over cos squared theta, which simply means cos squared theta. Of course, 1 divided by tan squared theta is the same as 1 divided by sin squared theta over cos squared theta, because tan squared theta is sin squared theta over cos squared theta, and this is simply the same as 1 times cos squared theta all over sin squared theta. So 1 divided by tan squared theta is simply cos squared theta over sin squared theta. So that's what I'm going to write here, times cos squared theta all over sin squared theta all over sin squared theta. That's the same as 1 divided by tan squared theta. 1 divided by tan squared theta is cos squared theta over sin squared theta. And this simply means cos theta cancels 1 here. Cos theta cancels 1 of the cos theta there. You'll be left with cos theta. And the answer is 2 times cos theta over sin squared theta, which is equal to 2 cos theta. I can write this way actually. Let me write it this way. 2 times cos theta times 1 over sin squared theta. and that's the same as 2 cos theta. 1 over sine squared theta is the same as cosec squared theta. So that's 2 cos theta cosec squared theta, which is exactly what the right hand side is. It can be a bit tricky, but if you are careful and you know the basic identities, you'll be able to do the proof. You'll be able to show that the left hand side is equal to the right hand side. And that's it, very, very simply. So let's pause for now and come back very shortly to continue with the next. Thank you very much and stay tuned.